Welcome. The topic we'll be discussing in this lecture is virtual memory. So it is quite similar to what we have discussed in operating system, but I thought I'll make a video on that. Okay. So basically, why we provide cache memory? Cache memory is actually used to increase the speed of the processor. The processor feels that the speed getting increased, right? So that is the job of the cache memory. It is developed to increase the effective speed of the memory system, right? Similarly, virtual memory is the architectural solution to increase the effective size of the memory. So basically, virtual memory provides an architectural solution to increase the effective size of the memory, in the sense that with virtual memory, even you can load a program into the main memory, even you can load such a program whose size is actually bigger than the main memory size, right? Say for example, your main memory is 4 GB only, right? But you want to load a program which is of 8 GB, which is of 8 GB, okay? Actually, it is possible with virtual memory, but if there is no concept of virtual memory, then that is not possible, right? So how it works in the sense, now you have only 4 GB of actual physical memory, that is main memory, but the processor want to load a program which is of 8 GB size. Here comes the concept of virtual memory, right? So typically the address bus of the processor may be huge. That is, it should be able to address 8 GB. That is important, right? The processor should be able to address 8 GB of memory, so that much address size should be there. But the system does not have that much main memory, it has only 4 GB. Okay. So now it is addressing an 8 GB memory, right? Now it is addressing 8 GB content, right? But this process, which is it is the system CPU is referring is 8 GB process, okay? But currently you won't load the entire 8 GB. We'll be loading only the 4 GB or even less than that, which may be which is expected to be used, right? So as long as CPU is referring to the address of this 4 GB, which is currently get loaded, it's not an issue, right? Whenever CPU want to address some location of the particular process which is not in the currently in the main memory, then there is something called as page fault will occur. Okay, we'll be discussing that in detail later. So now we have to do something called as swapping. That is, some content of the main memory should be swapped to hard disk, and whatever the content the CPU is asking, that such content should be brought in. Okay, so this is the whole philosophy of virtual memory. So with virtual memory only, we are able to execute programs or process which is larger than the size of the actual main memory, right? Say for example, if the computer uses 32-bit address, then with 32-bit address it can address up to 4 gigabytes of memory, right? Now if your system contains only 2 GB of memory also, you can, but the system can load even a 4 GB program with 2 GB of memory, okay? But it can load only up to 4 GB. It cannot load anything beyond 4 GB because you don't have even address lines to address beyond 4 GB. Are you getting? Because you have only 32 bits. With 32 bits, you can address only 4 GB of locations. Okay. So if the memory capacity of the system is 2 GB, it can even open a 3 GB program or a 4 GB program. Okay. So all these are possible because of virtual memory. How? As we have discussed already, the entire program will not be loaded. Rather a part of the program will be loaded. As long as CPU is referring to this part of the program or addresses of this part of the program, it is fine, no issue. But whenever CPU want to access the other part, then there will be page fault and then swapping will happen. Okay, fine. Okay, so physical memory, the physical main memory. Okay, main memory is called as physical memory. Is generally not as large as the entire possible address space. Okay, generally it may not be large as the entire possible address space. So here the address space is 32 bit. That means it can address 4 GB bytes, 4 GB memory. But generally, if you take any typical system, it won't use the entire address bus capacity will not be used by the main memory, right? Okay. So physical memory typically ranges from few hundred megabytes to 1 gigabytes. Okay, this may be a old information. So as of today's computer, it is very normal to have 4 GB memory, right? So even many of you may be having 8 GB or 12 GB memory, right? Okay. So as of today's scenario, 8 GB is very common. 8 GB is very common. Okay. So if you have an address bus, which can address only up to say it can address up to 16 GB memory. Okay, it can address up to 16 GB memory, and your system contains only 8 GB memory. Okay, then also you can load a program of size 10 GB or 12 GB. Right? Okay, fine. So that is the whole concept of virtual memory. Large programs that cannot fit completely into the main memory have their parts stored on the secondary storage devices. Okay, so the large program which will not completely fit on the main memory, only part of the program will be loaded. Remaining program where it will be stored, it will be in the secondary storage device or the disk. Okay. So and those programs must be transferred to the main memory whenever they are expected. Okay. Whenever CPU generates such address which is not a part of the main memory, but it is those contents are in the disk, then they have to be transferred to the main memory. Right? Okay. So sometimes so say CPU is requesting some content. That content is not in the main memory, so it should be brought from the hard disk. Okay, I will draw hard disk something like this. So it should be it should be brought from the hard disk to the main memory. Okay, as long as there is sufficient space in the main memory to bring this new page. Okay, it's not an issue, right? But say there is no sufficient space. The main memory is already full. Then you have to go for some replacement techniques. Okay, so this is similar to the cache replacement techniques which we have discussed, right? Okay. So all these things will be automatically taken care by the operating system. User need not do anything. Okay, the processor will generate the virtual address. So whenever you are using virtual memory, the address generated by the processor is called as virtual address or logical address. It's not the physical address. Okay. So the processor will generate the virtual address, and there is something called as memory management unit, which will convert the virtual address to the physical address, and then it will check whether the physical address referred is currently in the main memory or not. If it is available in the main memory, it's fine. CPU can access it quickly. If it is not available in the main memory, then it should be brought from the disk to the main memory. Okay. Again, when it is brought from the disk to the main memory, if there is sufficient space in the main memory, the new page will accommodate there. Otherwise again swapping will happen. Okay, that is replacement will happen. One of the page from the main memory should be replaced to the disk, and the new page will be brought in. Okay, fine. Okay, so there are certain techniques that automatically move programs and data between main memory and secondary storage depending on the requirement. Okay, so these set of techniques are called as virtual memory techniques. Okay. So basically, virtual memory, the concept of virtual memory is that even though your main memory does not have enough capacity, still you can load a program which is larger than the size of the main memory, right? In such cases, some data or program should be transferred between main memory and secondary storage device whenever it is required, because CPU may refer to that content which is stored in the secondary storage device also. Okay. So the set of techniques which takes care of this data transfer is called as virtual memory techniques. Okay, right. So processor will always issue a logical address. The issue a binary address. That means it's a binary number. The addresses are in binary number, and this address is called as logical or physical address. Okay. And the logical or virtual address. This address is called as logical or virtual address. The virtual addresses are translated into physical address by a combination of hardware and software. Okay. So if the virtual address refers to a part of the program that is currently in the main memory, it is accessed immediately. Okay. If it is not in the main memory, then it is first transferred to the main memory before it can be used. So this is the introduction about virtual memory. Now let us see exactly how virtual memory works with this diagram. So processor is going to generate a virtual address. Okay, right? So the virtual address goes to the MMU, memory management unit. The memory management unit identifies the equivalent physical address, and then it checks whether the particular address, whether the whatever the physical address generated, is that content is available in the cache or not. Okay. If it is available in the cache, fine, processor can get it very fastly. If it is not in the cache, then it will check whether it is in the physical memory or not, physical address that is in the main memory or not. Okay. The physical address generated will be first checked in the cache. If it is in the cache, it will be given to the processor. Otherwise, it will be referred in the main memory. If it is not in the cache, then check in the main memory. If it is available in the main memory, then transfer it to the processor. If it is not available in the main memory also, then it should be transferred from the disk. Okay. So again, while transferring from the disk, the memory management unit will check is there sufficient space in the main memory or not for transferring this particular page. If there is sufficient space, it can be transferred immediately. Otherwise, it should go for some replacement techniques. Okay, so this is the whole concept at the top level. Fine. Okay, so here we divide the program or process into set of fixed units called pages, right? For virtual memory, for implementing virtual memory, a program or process is divided into set of fixed units. Okay, these fixed unit, the size of each unit, the size is, these fixed sizes are called as, these fixed units are called as pages. Fixed units are called as pages. Okay. So what is a page? A page is nothing but a block of words. A page is nothing but a block of words which occupies some continuous location in the main memory. Okay. So page is the basic unit of information that is transferred between secondary storage and the main memory. Okay. So here we say everything in terms of page. Okay, right? Like how in cache we have discussed everything in terms of block. We say block. Okay. In cache memory and main memory, right? But for virtual memory, the program or the program is divided into pages, right? And in the main memory also, everything will be loaded as pages. Okay. So the basic unit of data transfer is in terms of pages between main memory and secondary storage device. Okay. The typical size of a page is this much, 2 kilobytes to 6 kilobytes. Okay. What is one page? Page is a collection of block of words, and the size of a page is from 2 kilobytes to 16 kilobytes. Not 16 kilobytes. Okay. So there is a small tip here given. Pages should not be too small, and also it should not be too large. Okay. Why it should not be too small? It should not be too small because you are going to move page from, when a page is not in the main memory. When the page is not in the main memory, then we are going to move the page from hard disk to the main memory. Okay. Now moving something from hard disk to main memory, it's a time consuming operation. Okay. So whenever you move something from hard disk to main memory, you have to move some sufficient content. Some good amount of content should be moved. Okay. For very small amount of content, then that is not advisable.